Welcome to Apigee Up Close webinar series. They happen twice a month. The topics are based on popular demand. You can ask live questions or send them in advance. And I am Nasir Mohammed, a customer solution architect at Google, and I specialize in API security. Joining me in this webinar is Chris Page, a customer solution architect. As a part of agenda today, I will start with a brief overview of Apigee Edge. Then we'll deep dive into Apigee Edge security. And then I will hand it over to Chris, who will demonstrate the threat protection aspect of security. While we are doing so, please post your questions in, and we will answer them at the end. Let's start with quick Apigee Edge overview. This is our design philosophy at Apigee. This challenges traditional approaches of API management. Traditionally, they think about this from an exposure point of view. They expose a set of services and publish an API catalog, and they think their job is done. Well, not really. Thinking about it from an end user point of view and working backwards from there leads to better results. Realizing the importance of each actor on this chain and providing them with enhanced experiences becomes the key for a successful API program. This outside-in approach is the underlying principle at Apigee, using which we have shown great success to many of our clients. Having said that, let's change the lens and look at this pattern from a security point of view. Indeed, the pattern covers a lot of ground, which opens up a need for a larger set of security controls. Each actor on this chain has a unique set of security requirements. Let us start from left to right following the outside-in approach. As we publish our APIs for end users, how can we protect these APIs from hackers who are trying to bring our systems down, and from data scrapers and bad bots who wants to steal our data? Thereby leading to the next question: how can I know the incoming calls are from legit users? And do they really have needed permissions to access these APIs? An enterprise can have many applications that access your APIs. How can I uniquely identify these applications? More importantly, as we are looking at it from a security and governance perspective, how can I ensure that the decommissioned apps can no longer access this API? Moving further in towards the right of the chain comes the app developer. App developer uses our APIs to create great applications. Now, how can we onboard these app developers? Remember, these app developers can be internal employees, third-party partners, and any developer on the internet. How can we register him and provide him with needed access without much friction? Moving towards the APIs and API teams, how do we ensure that the API developers are developing APIs that are secure and are not opening up any vulnerability? Are they adhering to enterprise security standards? Finally, on the backend, how do we authenticate backend? How do we pass in the originating user's information to the backend services? How do we secure data on wire and data at rest? Yeah, the list is long. We need an API platform that provides effective solution for all these questions. Apigee, as a comprehensive API platform, provides standards-based adaptive security controls, addressing those diverse set of security requirements. Apigee protects against hackers and data scrapers leveraging the Apigee Sense module, which is a behavior-based threat protection module. Apigee protects our APIs against threatening content attacks like SQL injections, cross-site scripting attacks, leveraging the signature-based threat protection policy. Apigee effectively controls spikes in traffic, thereby protecting our backend services from going down. Apigee identifies the applications based on API keys and authenticates end user leveraging the industry standard OWASP protocol. After identification and authentication comes the challenge of API authorization. Apigee introduces this concept of products. API products help you slice and dice your APIs in ways that makes business sense. These products, in turn, act as coarse-grained authorization enforcers. For finer-grained authorization, Apigee leverages OAuth scopes. Apart from that, products have assigned quotas for enforcing usage boundaries. And last but not the least, logging capabilities for auditability, thus covering identification, authentication, authorization, and auditability aspects of security. Apigee works with your identity and access management products like SiteMinder, Ping Federate, Okta, ForgeRock, etc. for providing single sign-on and self-service experiences for your app developers. Apigee supports OpenID Connect, JART, and SAML protocols to work with your partners in a federated fashion. Apigee provides global policies and flow hooks for abstracting, development, and enforcement of security policies from business API developers. Apigee provides developer portal as well as management APIs for provisioning and decommissioning apps and application developers. Apigee secures data on wire and in transit, leveraging one-way and two-way SSL. Apigee can also store your sensitive configuration elements in encrypted fashion, thereby providing confidentiality of your persistent data. This is a high-level overview of Apigee's security landscape. In this webinar, we will concentrate on the threat protection policies. With that, I will hand it over to Chris.
Hi, I'm Chris Page. I'm a customer solution architect on the Apigee team, which is part of Google Cloud. Today, I'm going to showcase how Apigee Edge can be configured to protect against threat protection. So the problem is when a malicious client can send malform requests to your backend services, as showcased in my diagram below. This includes all components that make up the HTTP request or message from those clients, whether it be TLS certificates, request headers, the payload, or even the query string fields and or parameters. Now, a client can be anything. It can be a browser, mobile device, a server, or even an IoT device. The API proxy layer should detect, block, and report any malform requests that are received from those clients before the requests are processed on the backend systems. Too often, this is an oversight and is not implemented or not even a priority when developers are building out backend systems. OWASP, which is the Open Web Application Security Project, is an open community that is dedicated to enabling organizations to implement web and API security best practices. OWASP publishes a top 10 list of the most critical security risks to web applications and APIs. Their latest publication last year labeled injection flaws as the #1 security risk. In this demo, we'll cover two of those topics. Input validation, which user-supplied data is not validated, filtered, or sanitized before the application receives it. It should only be applied to both syntactical and semantic levels. That's like structured fields and or value ranges, i.e. only permit valid payloads or depths and lengths. A key value is one depth, whereas key 2, key 3 would be multiple depths. And also validate query parameter fields, i.e. for this demo, I'm only going to validate the limit, name, and brewery key fields. Another example of injection flaws is SQL code injection, i.e. when dynamic queries or calls without any contextual aware escaping are used to directly hit the interpreter or the application context. I.e. let's search on the filter for parameter values where name equals delete from resource. This can be applied in addition to not just relational, but also NoSQL queries. And a lot of times it can be implemented on ORM levels, or object relational mapping, abstraction layers from the database that may have direct SQL queries implemented as well. Now, in this diagram, on the right-hand side, there is a RESTful beer service that is returning valid JSON data to client. We want to only allow good requests from valid clients and detect, block, and report on the bad requests from those malicious clients. The goals are create an API that protects against those injection flaws from the client requests, payloads, and query parameters. Keep it as simple as possible. Make it reproducible for any additional APIs, and also be able to report on the usage of those malformed requests. Now let's get to the API. Let's log into my Apigee Edge account and take a look at the proxy that I've already created for this demo. My proxy, my beers proxy, already has a deployment URL. You can see my FQDN here with the endpoint of /v1/beer. Here's my target endpoint or my backend beer service called v1 beer-backend. Let's take a look at the actual policies that we can run through with this proxy. You'll see that I have a couple policies that are already defined here. Out of the box, Apigee Edge includes a whole suite of palettes, a whole palette of different policy assertions with our traffic management, security, mediation for transformation, as well as extendability. Today we're just going to focus on a couple of the threat protections, JSON threat protection for input validation, as well as a SQL code protection and parameter validation for injection flaws. So on my details flow, I've already went ahead and created the JSON threat protection, parameter validation leveraging a JavaScript callout. I also have a custom fault detection for that JavaScript parameter validation, and then also SQL code protection. In a real-world production API proxy, you would also have some auth-N, auth-Z to identify the client, as well as any IP tables or restriction-based rules before any of these additional policies. Let's take a look at JSON threat protection as our first policy. We'll see that there's a couple different parameters or variables that are defined here. Array element count is the first one. That means that this JSON structure will not include any arrays. It'll just actually be a key value. And the depth of those values will just be 1. So there won't be any nested depth or nested key value objects within the JSON structure. We're going to keep the number of keys or the number of entries to 3, and then we're going to keep the length of those keys down to 50. In addition, we're going to limit the value of those keys to only be 255 characters. Now, Apigee Edge provides a real-time trace debugger, so we can actually go ahead and start looking at the requests coming in. I'll start with a couple of successful requests so that you can see that nothing is going to be triggered, and then simulate some of the input validation and injection flaws. Just minimize this. Awesome. So first, let's just do a simple get. Oh, and there's a return. Let's actually limit to 1 resource. There's a simple beer coming back. Let's try a filter. Equals 2. Excellent. You'll see that the first 3 requests came through as 200s. I can ignore that fat finger 404 that I just did. If we do a simple post, let's create a new beer. We'll just have a simple name be, I have a post with application content or content type application JSON. Name, the payload is a JSON structure with name and the value of the best beer. Say I got a 201 return back from my response. Perfect. Everything looks good. Now let's try and actually simulate some of that input validation to trigger those policies that I already have enabled. So for JSON threat protection, let's run through 2 examples of, let's do nested JSON and extremely large key values so that we can trigger and identify which ones are actually being captured. So first things first, let's try that post again. This time I'm going to do a nested structure as my value instead of just a standard name. Oh, immediately I got a 400 back from my Apigee Edge API proxy. You'll see that I have a custom fault string or fault message that is actually identifying the policy itself, which is JSON threat protection, and more details of exceeded the container depth at line 1. And we look at our trace session, and there's that 400. And if you walk through the trace path, you'll see that JSON threat protection was triggered right here. Excellent. Now what if I have a random array of strings that are over 255 characters? Let's try that same post method, this time with there it is, 400 immediately back from Apigee Edge, my API proxy, and you'll see the same policy was triggered, JSON threat protection, with a different value though this time, exceeded string value length at line 1. Likewise, there it is, I got the error right here on the JSON threat protection. Now, each time that actually occurs, I'm actually doing some additional logging. You'll see these other policies here that I'll get into, where I'm going to capture those error codes and we'll be able to report on later. But this showcases that with a simple drag and drop policy, you can configure and have those parameters defined to validate against JSON threats or within the key as well as the value and the structure itself. Now, for the next example, let's take a look at SQL code injection flaws, as well as URL parameter query strings. So let's go back to my policies, or my detail policy flow. Now, I have a couple additional policies out next to my JSON threat protection. The first one is parameter validation. And for parameter validation, I'm actually going to leverage our JavaScript callout feature, where I can write custom JavaScript and custom logic within Apigee Edge to manipulate the message or session, as well as define custom variables from the request coming in. So within my parameter validation JavaScript, I'm actually going to create a whitelist of parameters or query strings that are only valid for my backend client. In this case, I only want to allow the query string name, brewery, and limit to be able to be passed back to my backend resource. I set a custom fault response message here so that I can capture it if this parameter validation threat protection is triggered. And I'm actually going to go and iterate over the request parameters. I'll iterate over the whitelist to see if any of those request parameters meet one of those variables in the whitelist. Then I'll flag one, if they're true, they're good. If not, I'll flag them as false. And I'll actually set a context variable called parameter validation fault to set a custom fault message so that I can report on that accordingly. Once that custom fault message is set, I'll set a custom parameter validation fault message here, and I'll be able to report on that accordingly. Let's go back to my trace session. We're still running. Great. Let's simulate a successful call again with those query strings. You'll see there's that best URL that I just created earlier. Now, if I change my query parameter, in addition to limit and name, if I add, let's say, test equals 123, which was not a valid parameter, immediately I get a 400 back from my Apigee Edge API proxy. And here's a different definition, or a different policy name, parameter validation. Execution failed, reason test is not a valid parameter. That is true. That wasn't one of those whitelisted parameters that I defined in my JavaScript callout. And you'll see right here that the JSON threat protection was not triggered, but the parameter validation went through. I iterated over those three values, and then I set this fault that this was triggered, and then I caught that fault and I raised the fault based off my parameter validation. Just as like that, you can have whitelisted parameters that you can call out in addition to JSON threat protection for injection flaws. Now, what if the client is going to send those malformed SQL code? Let's go back to my policy, and here is SQL code. This is actually a SQL code protection policy where I'm allowing Apigee Edge to identify the invalid SQL that is being sent by the values of those query parameters within name. So whether it be the query, the header, or the form, I have a set regex, which was defined by OWASP, where delete, execute, drop, insert, shutdown, or update, or any of those standard relational SQL or NoSQL queries can be captured, and this policy can be triggered. So let's take another example. Let's go back to my trace session. So if I do a get, this time, let's change name to be delete from brewery. Let's try that. Oh, just like that. Once again, I got another 400 back from my Apigee Edge API proxy. And you'll see this time it's a regular expression detected, and actually I'm identifying delete from brewery was the invalid parameter or invalid value for that parameter. Now if I go back to my trace session, let's skip over here, and you'll see that the SQL code protection was actually triggered this time. Just like that, in those 3 policies, I was able to do input validation through nested JSON and JSON string length, as well as injection flaws from query parameters and SQL code injection failures. Now, I did mention that I needed to capture, I had some additional policies to capture those analytics, because the idea of the API proxy is not just to detect and block those threat protections, but also report on them too. So I have these additional fault response flows right down here, where I'm going to extract the error codes that are coming back from those fault response. And I'm going to try and capture that error code variable so that I can report on them through our Apigee Edge's analytics. Now, that value right here is actually just a key value error code with the value here. It is steps regex protection. And if I look at the other one, it is steps parameter validation. So within this policy, I'm actually doing a JSON path on that variable or on that detail error code variable, and then saving that as a context variable called fault error code. That fault error code is now going to be leveraged through our fault collector. And this fault collector is basically a statistics collector that will capture that variable and set it as a new value within our analytics so that I can report on it. So that fault error code variable will actually be set as fault underscore error underscore code within my analytics. I went ahead and already created a report. Let's see if that is available. It reports on those error codes based off of the sum of traffic. So if I go into this report, oh, there it is. You'll see that I am capturing each one of them. It looks like there's the threat protection, here's the parameter validation, here's a regex protection. Looks like I have a couple ones that are not set that I'll have to go back and clean up to make sure that they're not being sent anonymously. But just like that, you're able to protect within Apigee Edge for threat protection of injection flaws, as well as input validation, and then report on them within our analytics platform. And that concludes this demo. Thank you very much. Let me know if you have any questions.
Thank you for really, really wonderful demo there. All right, so we'll take a pause here for question and answers. So guys, please do ask your questions. I'll be following through the Q&A channel here. So the first question in here goes as follows. Can Apigee be configured to detect false positives while performing signature-based threats? Using our current WAF and a cloud-based firewall, we can block the calls that have threatening signatures, but they do not tell us why the calls were blocked. Can Apigee provide additional information on why the request was blocked? So that's the question. Yeah, and yeah, so we have seen this before from many of our clients as well, who are using WAFs or any firewall in the networks, right? When it comes to threatening content protection, it is very important for us to get the signatures right. At times, what happens is, you might have a signature or regular expression that corresponds to a signature, and it might also capture or mark the requests that are not really threatening content, or the requests that did not really have any content that was threatening, but was a false positive. So yes, in Apigee, you can configure your threatening content policies to report back onto why the call was blocked. Thereby, your developers can go back and can see why the call was blocked, or it can go to your analytics consoles or your logging systems, whereby the operations folks can go and see why a particular transaction was blocked. Hope that answers that question. So the next question I have here is, can Apigee be integrated with cloud-based identity solutions like Okta? Yes, we have many of our clients who are using Okta and are also using Apigee for API management. The general answer, yes, the answer is yes for Okta, but in general for any cloud identity solution, as long as the cloud identity provider supports a SAML protocol or OpenID Connect protocol, we can work with them. We have also worked with some of the cloud providers that really do not support a fully OpenID Connect protocol, but they have OAuth implementation, which we can integrate with as well. So the short answer is yes, we support Okta, the cloud-based identity solution. So there's another question here. How can I configure behavior-based threat protection module? Where can I set the upper limits and lower limits of, for example, a brute force attack? So that's interesting. So what we have seen in this demo today is signature-based threat protection, right? So there's also a complementary aspect of signature-based threat protection, which is also known as behavior-based threat protection. Apigee has a product called Apigee Sense that does provide those capabilities. And Apigee Sense provides, it provides you settings that are based on convention, based on our experiences as to how you mark a certain attack as a brute force attack or a password guesser attack, right? And then out of those settings, we give full control to our customers to come and fine-tune those settings based on their needs. So yes, Apigee does provide you configuration capabilities to configure your behavior-based detection algorithms based on your inputs. So I hope that answers that question.
Okay, let me check on one of these other next question. Does SQL code protection only apply to relational databases? Now, that's yes and no. There's a common misconception that if developers are not writing SQL queries for NoSQL databases, that SQL code injection is really not applicable. There are definitely well-known NoSQL vulnerabilities via associated arrays and where clauses. You can definitely check out on some of the Black Hat and OWASP websites, but there's some documentation for testing against SQL code on NoSQL data stores.
Sounds good. So the next question that is in here is, should an ORM database framework library handle all SQL injection protection? That's a good question. So, the best practices for security is to block the threatening content before it comes to your, to further, that are way on the database side. So, for example, let's say your ORM basically sits in your intranet right where the data is. So the fact that the threatening content vector reached and managed to reach at that level in itself is a risk. So, we definitely want our ORM databases to implement SQL injection protections, all right? But it should be handled on the edge of the API gateway layers so that, we provide the first level of defense, which is our API gateway, making sure that there's no threatening vectors or signatures that are coming in and protected over there. So the answer is yes. The protection should be on the ORM as well, but it is always best practice to protect the calls at the edge layers. So I'll take up the next question as well here. Can Apigee prevent the malicious requests, or can it only detect? If it can prevent, can this prevented malicious calls be reported to our incident management teams? That's a good question. So yes, Apigee is both works both as a detection and prevention mechanisms. So it has detective controls and it has preventive controls as well. Apigee can very well, like Chris showed in the demonstration, can detect and prevent and block the call right there. If you want, Apigee can also detect and report the call. I think that's the question. That's where the question was leading towards, right? So it can definitely detect and notify an incident management team to take appropriate actions. Obviously, the preferred approach is to prevent and detect at Apigee, and after detection, block the call and then notify to the incident management team so that the incident management team can take appropriate actions on that. Hope that answers that question. Chris, you want to go for the next one?
Sure. Here's a question. Do you have to have customized SQL injection regex for threat protection or something universal which can be used? So there's a wide range of threat protections that can be identified from the communities, and there isn't one unique regex that would solve all. So you would basically define those unique regex patterns based off of that particular threat. The next one, is there a list of out-of-the-box security policies that you would recommend to use as a starting point for most APIs? Now that's a good question. A lot of times we hear that. What are those best practices from our customers of what security policies should be applied to those APIs? And it's really going to depend what type of API it is. Is it is it a SOAP-based service? Is it a RESTful service? Is it a public-facing? Is it an internal API? We have, a lot of those threat protections we would definitely implement for those APIs right out of the box. We also have a couple other policies within our palette that we didn't go into depth within this tutorial or this webinar. Some like verifying client quota or rate limiting or spike arrests would also be applied as best practices. And you can find out more of them through our community and our doc sites within the resources tab.
I have two questions here which are related. How do you validate the input request parameters with the data types? Example, if I want to send age parameters, I would not like to take a character input. So that question and the question about it, also can we validate the URL parameters and body payloads validating against a JSON schema? So, it's a data validation question. Yes, you can validate your input incoming requests against like JSON schema or XML schema, and the schema validation is definitely a very first step for you to validate the data. You can definitely do that. What you can also do is, because we are focused on threatening content protection, right? We can also validate the complexity of the JSON. There are few attacks that are sophisticated in the nature that, they try to emulate a denial of service attack by sending a huge JSON payload or an XML payload that your backends cannot handle, right? So Apigee can definitely, Apigee has this complexity policy where you can define your complexity levels, saying that the allowed max cap or number of elements in a JSON payload is, let's say, 50. So anyone who's trying to send more than that, we will mark that as a threat, right? So that we can do that. So the answer is yes. Data validation can be done via schema. XML schemas and JSON schemas, you can actually go a fine grain and you can pick query params or HTTP headers and also validate the data using our script filters. And then you can take that to the next level where you're also adding the complexity filters on top of it. Hope that answers that question.
These are great questions.
I think, Chris, we went through all the questions here. There's a question also that says, I want to be an expert in Apigee. What do I need to do? So, Apigee has, so first thing you have to do is log in, create an account, start using Apigee. The more you use, the more use cases you implement, the more you learn about the product itself. But having said that, if you want to become an expert in Apigee, you also broaden your view of API platform. It's not just the API gateway. There's more to it, right? Like we started in the slide, right? There's a developer portal in Apigee. There's also recommendations on how do you document your APIs. How do you publish your APIs? Apart from security, there are more other features that that are there that Apigee provides. There are also regional API jam sessions which we conduct. You're free to join any of those sessions, wherein it's a one-day session. You come in and it's I think it's a 5-hour session where it's a deep dive into the product. You're basically building APIs, configuring developer portals and all that. By the end of that, you would actually become an API ninja. So watch out for these regional API jam sessions. If you want a specific API jam session for your organization, you're more than welcome to send out a request, and we'll do the best to cater that.
Looks like there's about 1 or 2 more questions. I can take these, Nasir.
Sure, go ahead.
Why isn't the client authenticated before the threat protections? I think the way I interpret it is, why is the client not identified before the threat protections are implemented or exercised? Well, in the real world, API security best practices, yes, the client really should be authenticated before inspecting that payload, queries, et cetera, to identify really which client and what client is sending the malicious data. Best practices are fail fast before, requiring additional system resources for inspection of, the request payload. Typically, auth-N or auth-Z will be covered in a future Apigee Up Close and security webinar. How can you monitor, next question, how can you monitor malicious clients and pattern matching or rule-based filters? That's a great one. So Apigee does have a product called Apigee Sense, which does specifically that. It applies adaptive API security, it's a product to mitigate sophisticated bot attacks. It leverages machine learning and detects anomalies based off pattern matching at the API layer. You as an administrator have the ability to create dynamic rules or custom rules based off of that pattern matching that the product provides. Also enables you to take action on those bots you find, whether it be throttle, block, log, etc. And we also have another session within Apigee Sense that is coming up in a couple weeks. I think that's it for the questions. I appreciate everyone's input. I'd just like to leave off with some follow-up documentation. Our next webcast is Tuesday, March 6th, How Secure Your APIs. We also have an in-depth tutorial you can join via our virtual API jam. And for any one-on-one sessions or additional questions, please reach out to Michael Lofquist. His email is mlofquist, Lofquist @google.com. And all additional documentation links are in the resources section. And that's a wrap. Appreciate everyone joining this webcast today. Look forward to seeing you in the next one.